Hello students. Now we would be doing question number 11 and 12 of this lab 2 task sheet. If we look at question number 11, it is asking us to perform the hypothesis test at the 5% significance level. Then the fitted model is a good model. So this is in fact the testing of R square based on F distribution or F test given in analysis of variance table. Just have a look on this analysis of variance table, what we have we got when we have fitted the model on the data. This is what analysis of variance table. Now we need to and try to understand the components involved in analysis of variance. What analysis of variance is for. Let's suppose when we are going to examine the relationship between two variables, so relationship can never be perfect, because we are defining a relationship or its nature in terms of simple linear regression model, and only one variable we are assuming, which is an independent variable. We are assuming that it is causing a change or effect in the dependent variable or on the dependent variable. So that's not the case, because this is very simple. Let's consider the example of study time versus marks. The study time, yes, it has an effect on your marks, but what if the two students are devoting the same number of hours or increasing the similar number of hours? Is it necessary that they will get same increase in marks? The answer is rarely it happens. Same over here. We have in fact taken this relationship that weight is affecting or influencing the price of diamond in the market, but that's not the case. Besides weight, there are maybe so many things, so many other factors that may have an influence on the price determination in the market. If we change its weight, its color, some colors are more demanded, okay, and clarity is another perspective, and then the brands that is going to certify that diamond. Again, these three important factors may have a significant effect. So we never get a model that has R square perfectly equal to 1. That is not practically possible. But R square we interpret, when we interpret R square, over here we can see that it is not perfectly 100%. It is 97.8% variation in price according to this data can be explained by the variation in its weight. A very good model, but it is still unable to cause 100% variation in price or responsible for 100% variation in price. So we need to understand the part that we call explained variation and then compare it with unexplained variation, because both combining together will cause the total variation in the data or contribute to the total variation of the data. So over here in this ANOVA table, you can see sum of squares, sum of square of regression, that we can alternatively call explain variation due to the fitted regression model, that is weight is causing variation in price, and residual sum of square represents the extent of unexplained variation. There is some part of the variation in the data that regression model or fitted regression model is not able to explain. So these two further adjusted for their mean values, that is we divide by the degrees of freedom. Over here you can see we have taken only one variable into consideration. There are two parameters in the regression model that we have fitted. So k minus 1 would be the degrees of freedom over here, and n minus k minus 1 would be the degrees of freedom for residual or error, that is the extent of unexplained variation. What k represents over here? K represents the number of parameters in the regression model. So this is how we write down the F ratio formula, because this is mean. Mean we get when we divide sum of squares, regression sum of square, by 1 or by its degrees of freedom. We get mean sum of square of regression, and then we get mean squared residual when we divide sum of square residual by its associated degrees of freedom. So I'm going to do the write up of this test now. How do we write up this test? H naught in H1, the fitted regression model or the fitted model is not a good fit. The fitted model is a good fit. Level of significance is alpha 0.05. Test statistic is F, that has a formula sum of square of regression divided by k minus 1. Over here k represents the number of parameters in the regression model strictly, and then SSE divided by n minus k, which is representing the number of parameters. There are two parameters in the regression model. Okay, so total number of observations are 48. Beta naught and beta 1 are the two parameters of the regression model. Now we define decision criterion as usual. Which is mentioned already in the table in the form of F distribution and it associates significance. We say again that H naught would be rejected if p value associated with F statistic that we can find in ANOVA table is less than 0.05. Now decision and conclusion we can write down over here. Look at the significance associated with F statistic in ANOVA table is 0.000 because F value is very large. Since p value associated with F statistic is less than 0.05. Therefore, H naught is rejected and it can be concluded that the fitted model is a good fit. This is how we perform testing for goodness of a fit of model. Now, going to the last part of this, we go for testing the hypothesis that the price is a useful predictor of yield. So to understand this concept, we need to understand that we refer independent variable as a predictor as well and dependent variable as response. So when we make any changes in the predictor, it will influence, it will affect, it will give change or reflect change in the dependent variable, and the dependent variable responds to that change. So that is why we call it response variable as well, the dependent variable. So H naught we state in H1 we state as weight is not a significant or useful predictor of price. And here again I missed out weight of diamonds we are talking about. So understood, this is understood that we need to mention it as weight of diamonds. Weight is a significant or useful predictor of price. Level of significance alpha equals 0.05. Test statistic is T is equal to B1 minus beta 1. What is B1? B1 is the sample statistic, sample regression coefficient for the slope we call it, whereas beta 1 is its corresponding population parameter. And here we mention standard error B1. Now decision rule or criterion remains same. We state it as H naught is rejected if p-value associated with t statistic is less than 0.025. Over here again I would mention rather this as a two-tailed test, because we are just stating in H1 that it is a useful predictor. We are not mentioning the nature of relationship. Therefore, it should be performed as a two-tailed test. In fact, when rejection goes on, in the right tail or in the left tail, it will automatically tell us that the nature of relationship is positive or negative. Now, decision and conclusion we write down. And for this, we need to look at the results in the coefficients table. In coefficients table, you can see that the weight has a t-value of 45.497. That is indicating again a positive relationship because t-value is not negative, it's positive. And corresponding or associated significance is 0.000. So H naught is clearly strongly rejected. Since p-value is 0, in fact, we had to write down p-value associated with. So this is what I am writing down over here as a connecting statement. P-value associated with t statistic is 0. Therefore, H naught is rejected, and it can be concluded that weight is a useful or significant predictor of price variable. If you can take notice of the value, t value, or the sign of the t value is positive, so we can further add more words to it because rejection with a positive t value is indicating rejection in the right tail, and rejection in the right tail indicates that there is a significant positive relationship between weight and price. So this is what you can add on your own in the end of the statement, stating it as since the sign of the t ratio is positive, it indicates the right tail rejection or rejection in the right tail. And furthermore, it can also be concluded that the nature of relationship between weight and price is positive. That's all for this session, from this session. Okay.